Okay, so now we're going to have a look at applications of the factor theorem where we might not actually have to apply long division processes. So it all hinges on the fact that we're trying to find factors of the constant that will give us a result of 0, and also that this is a polynomial of degree 4, so there should be no more than 4 roots of the polynomial. So if we can find our 4 roots by using the factor theorem, then there's not going to be a need to apply long division processes. So we'll start with the easiest one first to see if we can verify if 1 is a factor. So 1 to the power of 4 minus 1 cubed minus 7 times 1 squared plus 1 plus 6. 1 minus 1 is 0, negative 7 plus 1 is negative 6. Plus 6 gives us 0. So therefore, 1 is a factor, so x minus 1 is a factor of this polynomial. Now we're going to test if negative 1 is a factor. So negative 1 to the power of 4 minus negative 1 cubed minus 7 times negative 1 squared plus negative 1 plus 6. Now remember, this is really easy when you've got your calculator, because all you need to do, if you're typing each of these in brackets, then you just go back and use your edit function on the calculator and change the number you're substituting. So you can do this process really quickly using your calculator. Just keep in mind, as I've said, put what you're substituting in brackets and just change these values each time you make a substitution. So then we end up with 1 plus 1 minus 7 minus 1 plus 6. 1 and 1 is 2. Minus 7 is negative 5. Minus 1 is negative 6 plus 6 equals 0. So this is also a factor. So that means x plus 1 is a factor of this polynomial. So we've already identified 2 roots. Remember, we've only got at most 4. So the next logical one to probably try would be 2. So let's find p of 2, which is 2 to the power of 4 minus 2 cubed minus 7 times 2 squared plus 2 plus 6. So 2 to the power of 4 is 16 minus 8 minus 7 times 4 is 28 plus 2 plus 6. Now 16 minus 8 is negative 8, minus another 28 is negative 36, plus 2 plus 6 is not going to give us a result of 0. So therefore, this is not going to be a root of our polynomial. The next logical one for us to try would be p of negative 2. So this is the process that you can go through if you don't want to embark on full long division to find all the roots of the polynomial. But if you love your long division, remember you could come back here, and once you've identified these roots, you could multiply these two polynomials, x plus 1 times x minus 1, which is nice and easy because that gives you a result of x squared minus 1, and you could divide this polynomial by x squared minus 1. I'm just showing you another process, so if you want to avoid long division, you can in some cases. So now we're going to substitute negative 2, so negative 2 to the power of 4 minus negative 2 cubed minus 7 times negative 2 squared plus negative 2 plus 6, which will give us 16 plus 8, negative 2 squared is 4 times negative 7 is minus 28, minus 2 plus 6, 16 and 8 is 24, minus 28 is negative 4, minus 2 is negative 6, plus 6 is 0. So therefore we found another root. So x plus 2 is also a factor. Okay, so remember we're looking at factors of 6. So the